There's a project that I found some time ago that is called eCapture. What this does is like it basically allows you to capture SSL and TLS traffic in plain text without a certificate or without setting up a man-in-the-middle proxy.
Yep.
And as you can see, it's supported on Linux, Android, AMD, and ARM64. So the gist of it is that you download this binary. The documentation is quite extensive. It's becoming quite a popular project. So you download this eCapture binary, and then what you can do is like you need to run it as root, of course, because in order to like call the eBPF syscalls, you need like elevated privileges. As you can see, you have like different flags. You can either instrument not only SSL, but also you can instrument like bash commands, GNU TLS, gnutls. You can instrument gotls, MySQL, Postgres, like standard TLS, and so on. Since we are doing a Docker pool, what happens when you do a Docker pool is that the CLI, the Docker CLI, communicates with the Docker engine, right? And the Docker engine is the one that actually pulls the image for you.
Yeah.
So in this case, we want to instrument the Docker engine binary. And because it's a Go program, you need to use the gotls feature of eCapture. So you need to do eCapture, gotls, and then you need to supply I think it's elf binary, elf file. You need to supply an elf path, which is ELF is basically the standard of the file definition binary format. So ELF path and then user pin docker-d. In case you didn't see it because I was typing a bit fast, I basically supplied the docker-d binary, and this is gonna basically run the eBPF program, and it's gonna basically hook to the underlying syscalls that Golang does. And the reason why this is different than standard TLS is because Go has its own. When you build Go with a statically linked binary, it is not going to use the libc TLS implementation. It's not going to use like a libTLS. It's going to use its own SSL implementation. That's why. And it's going to basically do its own syscalls, its own like basically handling of all that part of the stack. So that's why you need to run it in this mode only for statically compiled binaries, which is the case of Dagger.
And Docker is already running, right? So Docker, you didn't have to change anything about it. That's already running. All that you did is basically you started eBPF trace, was it?
Yep.
Trace?
eCapture.
eCapture. You started eCapture. And you just basically attached it to something that's already running.
Yeah, exactly.
Elf path, and now it's introspecting all the HTTP calls.
Exactly.
HTTP
so now,
calls.
Yeah, it's going to introspect all TLS calls. I don't know if it's going to introspect like non-TLS. I haven't tried, but anyways.
It's all TLS calls. Cool.
Yeah, so now you can do a Docker pull, and we are going to pull Alpine, bloop. And as you can see on the right, it's already showing things. So we can start from scratch. So this is when the program started. So now you can see that the first thing that the client does is basically try to communicate to this endpoint.
Yeah.
Right. And then it's going to receive. Yeah. And then you get a realm, right? And then you're going to get an authorized, right?
You have to get the token before you can.
You need to get a token. Here you can see that I have the authorization header, right? I think it got this response because I'm already authenticated, so it probably used like a refresh token or something. But then here you can see the response. This is like a request. Here you can see the request header to request a token. You can see the response, right?
Yes.
Okay, application JSON, whatever, and then you can see the response body, right? This is the new token that the service is sending me. Yeah. And this is where the important part comes, which is what Matthias was explaining, and he's going to go back into this in a minute, which is, okay, now I do a head request towards this path, right? Like V2, library, Alpine, manifest latest against registry1 Docker.io. And this is all the request headers that I sent, right? This is the token. This is all the accept headers that the registry basically validates in order for the manifest to be on the same specification that the one that I'm requesting. And then what you get back from this, it's an okay, right? Yeah, I didn't get anything else because I already have the image locally, right? So it didn't have to pull the image. If I'm about to, let me clear this out.
What happens if you pull a registry Dagger.io, if you pull an image that you don't have? I'm very curious to see those requests. What do we see What endpoints do we talk to?
Let's pull V18.1.
Oh, wow. That's a lot of data.
I'm getting the binary data of this because it's like basically pulling the layers. Yeah.
Okay.
But
so that's going to be a lot of data.
So here's the beginning. Again, I'm doing as you can see, I'm doing the token handshaking part again, right? Because it's a different endpoint. Here, I got like a gzipped response. So in this case, it's funny. When you talk to Docker Hub, you get this in like a plain text. But in this case, it's basically compressed because it's like content encoded in gzip.
Yes.
So you don't get it. So it's going to be lighter, right? Because it's like compressed. Now I do like the same head request that we saw before for Alpine. I do it for the manifest that I've just requested, right? And in this case, I get the manifest, as you can see here. This is the manifest of the image, right? And as you can see, this image has the, because I'm already in an AMD 64 machine, this is going to result to the AMD 64 manifest. And as you can see, I get all the layers of that manifest. I get the digest, the layers. I get basically all the layers that need to be pulled. And I would assume that after this, it's going to start pulling each layer. So let's see, there are a bunch of layers here. And then after this, I get a temporary redirect to go. Yeah, this basically requests, once I get this endpoint, there should have been a path above that we're not seeing. But the program should have requested a layer. And in this case, GHCR, which is the underlying registry, is basically sending me a redirect to their CDN, right? So as you can see, this is basically the CDN endpoint that has the blob and the HMAC signature on the URL to basically give me like a short-lived URL, so I can pull this from here. And then once this is, I got another one here, because I would assume that the client can do this in parallel, right? It can pull like multiple layers in parallel as long as they are not like specifically dependent on each other. And once this happens, this basically just starts pulling the binary data. As you can see here, this is raw data. And that's pretty much it. So it's like basically like a 4-step process. Like one.
Can you scroll up just a little bit? Basically go to the response of the blob, like to the
headers.
Yeah. So that's the interesting thing. Like the thing that it's very useful to debug what's happening when you build like a CDN. You can see a few headers there that says xcache miss, hits, and all those things. That's basically coming directly from Azure. It's like this kind of tooling for building CDN, building anything that does anything with networking. It's a lifesaver. Like it's very, very cool. Yeah. It's a type of tool that I was like, what was I doing before? Like, what was my life like before knowing about it?
Yeah, honestly, I think this is essential. Like whenever you're trying to even figure out what's wrong with a system like this, you need to have this level of understanding of which are the endpoints that you're hitting, what are the headers that you're seeing, is a sequence of requests, does it actually make sense? Are you sending the right token? At what point of the stack? Because we have so many services here, right? We have the token service, we have the registry, we have GHCR, then we have the blob storage. There's so many moving components. And it's a global system. That's the other thing. Very few of these items are actually local. Even our own registry, like the registry proxy, registry Dagger.io, it's a global system, which is why replacing it with something else needs to be at the same global scale. We can't just, for example, go to ECR and publish the image there. That's not going to work, right? We need a global distribution because of the volume that this registry is seeing. And if this doesn't work, a lot of Dagger workflows would stop working. And there's a lot of workflows depending on this functionality. It has to be fast and it has to be always available.